Good afternoon, all. You have completed your semester 1 examination, and today onwards we are going to start our portions to the second semester. Okay, and we are going to start with the topic ion. Ions. Already we have discussed what is ion in our last class. What are ions? Ions are charged particles, right? Or uh, charged atoms are called ions, right? For example, K plus, Cl minus, Na plus, Mg2 plus, O2 minus, F minus, Ca2 plus. All these are ions, right? Why they are called ions? Because they are charged. How are they getting charged? By either by donating or accepting electron, right? Atoms combine with other atoms either by donating or accepting electrons. So those atoms which donate electrons are positively charged, okay, and those atoms which accepts electrons are negatively charged. If an atom donates 2 electrons, it will become 2 positively charged. If an atom donates 3 electrons, it will become 3 positively charged. Okay, and if an atom accepts 1 electron, it will become negatively charged, 1 negative. And if an atom accepts 2 electrons, it will become 2 negatively charged. Okay, so that's how atoms are getting charged. We have already learned these things in our last class. Okay, now we are going to discuss about molecules, charged molecules. Okay, charged molecules. For example, NH4 plus, NH4 plus. Okay, this is called ammonium ion. SO4 2 minus, SO4 2 minus, OH minus, NO3 minus, NO2 minus. All these are called ions because they are also charged. Ammonium is positively charged, SO4 is negatively charged, okay, and hydroxide group is negatively charged, nitrate negatively charged, nitrite is negatively charged, and these charged molecules are called polyatomic ions. Polyatomic ions, okay. Already we have learned what is ion, and now we are going to discuss, or we have learned what are polyatomic ions. Polyatomic ions, okay. Different atoms combine together to form molecule, right? And if the molecules are charged, if they are getting charged, they are called polyatomic ions. Okay, examples: ammonium. First one is ammonium, okay. Second one is sulfate. Sulfate is an example, SO4 2 minus, okay. And hydroxide, nitrate, nitrite. All these are example for polyatomic ions, okay. And phosphate, PO4 3 minus, phosphate, okay. All these are examples for polyatomic ions. What are polyatomic ions? Charged molecules. Charged molecules are called polyatomic ions. Have you understood polyatomic ions? Now we'll discuss another important topic, that is valency. Valency can be defined as the combining capacity of an element. Combining capacity. We know that elements are combined either by exchange of electron, right? Either by exchange of electron or by sharing of electron. If two elements are combined, by exchange of electrons, then it is called ionic compound. Such compounds are called ionic compounds, okay. if the compounds formed by combination of two elements by sharing of electron, then it is called covalent bonding. We will discuss in detail about this later, okay. But you just understand, elements are combined either by sharing of electron or by exchange of electron. Okay, already we have learned all these things in our last classes, okay. For example, we know that sodium has an atomic number 11, electronic configuration. About this electronic configuration we'll discuss, we learn in our next chapter, okay. So this is how the electrons distributed in the sodium atom. And what is chlorine atomic number is 17, and the electronic distribution in chlorine atom will be 287. And as I told you in the last class, octet rule, you might have heard about octet rule, okay. An atom with 8 electrons in its outermost shell is stable, okay. So all the atoms will try to get octet, or will try to attain octets, right? So that's why sodium will donate 1 electron to chlorine to become 2,8. Now the outermost shell consists of 8 electrons, right? That's why it donates 1 electron. And by donating 1 electron, sodium will become positively charged, okay. And chlorine require 1 more electron to get 8 electrons in the outermost shell, right? And that's why it accepts 1 more electron to be 8 in the outermost shell. By receiving 1 electron, it will become negatively charged. So sodium atom donates 1 electron, okay, and chlorine atoms accept 1 electron. The number of electron exchanged or donated by sodium atom is its or it can be called as its valency. That's the combining capacity of sodium. 1 electron is donated by sodium, right? And number of electrons donated or number of electrons exchanged by sodium atom is known as its valency. Similarly, chlorine atom has accepted 1 electron, right? 1 electron. So how many electrons are accepted by chlorine? 1, right? So that is known as its combining capacity. It can accept 1 electron, and that is actually what we called valency. Valency of chlorine is 1 because it can accept only 1 electron. So the number of electron exchanged by elements when they take part in a chemical reaction is called as its valency, okay. So for example, magnesium atomic number is 12, electronic configuration is 282. So whenever it take part in a chemical reaction, it will donate 2 electrons, and that's why the valency of magnesium is 2. Magnesium valency is 2. Understood? Next one, oxygen atomic number is 8, electronic configuration is 6. It required 2 more electrons to attain octet, right? 2 more electrons are required to get 8 electrons in an outermost shell. So it will accept 2 more electrons, and the valency of oxygen is 2. So that's how we calculate the valency of an element. Have you understood? So what is valency? The combining capacity of an element, or the number of electrons donated by an element, can be called as its valency, or number of electrons accepted by an element can be called as its valency. Okay, so the combining capacity of an element or number of electrons exchanged by an element when it take part in a chemical reaction is called as its valency. And all the elements will have their own valencies, and we need to by heart those valencies. Okay, now we are going to by heart the valencies of elements, so many elements, okay. And before that, you should have an idea about the periodic table. We know that you would have seen a table of elements, a table in which the elements are arranged in different rows and columns, and that's what we called a periodic table. Okay, elements are arranged in different rows and columns in a chart, and that's what we called a periodic table. Okay, I'll send you the picture of a periodic table, and before that we have to do one thing. You should have an idea about the periodic table. We please understand, periodic table consists of 18 groups. Okay, 18 groups. The columns, the vertical columns in the periodic table is called as a group. Vertical columns in the periodic table is called as groups. Okay, and it consists of 18 groups. 18 groups are there, and we have to by heart at least few elements from this periodic table. So the first group consists of elements such as hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. You have to by heart at least these elements in the first group. First group consists of hydrogen, lithium, sodium, potassium. Okay, and second group consists of beryllium, magnesium, calcium. Beryllium, magnesium, calcium, strontium, barium, radium are there, but at least these elements should be there in your mind. Okay, now we'll study about the 13th group. Okay, and 13th group consists of many elements are there, but you have to by heart boron, aluminium, at least boron, aluminium. Okay, 13th group. And 14th group carbon, silicon. By heart this. Okay, these are very important topics that we have to study for the next academic year. Okay, carbon, silicon. 15 nitrogen, phosphorus. At least nitrogen, phosphorus, arsenic, antimony, bismuth are there, but at least we have to by heart these two, nitrogen, phosphorus. And 16th group oxygen, sulfur. Okay, then we have 17th group fluorine, chlorine, bromine, iodine. Fluorine, chlorine, bromine, iodine. Fluorine, chlorine, bromine, iodine. Fluorine, chlorine, bromine, iodine. Okay, and 18th group helium, neon, argon. At least these elements, krypton, xenon, radon are there, but at least you have to study these elements by heart, these elements, because we know that, or you should know that all these first group elements will have the valency 1. That means they will donate 1 electron whenever they take part in a chemical reaction. And this one, all the second group elements will be having the valency 2. That means they will donate 2 electrons whenever they take part in a chemical reaction. Okay, and 13th group elements will be having the valency 3. So they will donate 3 electrons when they take part in a chemical reaction. Okay, and 14th group elements will be having the valency 4. 14th group. Okay, valency 4. Because they'll share 4 electrons. They will not donate. They'll share 4 electrons whenever they take part in a chemical reaction. Okay. Then 15th group, again valency 3. 15th group valency 3. Because let me explain this. Okay. Why they are donating or sharing electrons? To make 8 electrons in the outermost shell, right? For example, beryllium. Okay, let's discuss about aluminium. Aluminium is in the 13th group, right? Aluminium is in the 13th group. Atomic number 13, electronic configuration will be 283. So in order to obtain octet, it has to donate 3 electrons from the outermost shell. That's why the valency is 3. But here, nitrogen, atomic number is 7. Okay, atomic number is 7. Nitrogen, atomic number is 7. Electronic configuration will be 2 5. 2 5. Okay. It will accept 3 more electrons to be stable. 3 more electrons to be stable. That means to make it 8 at the outermost shell, it requires 3 more electrons. And that's why the valency of nitrogen is 3, because it can accept 3 electrons to be stable. Then oxygen, we know that oxygen atomic number is 8, so electron configuration will be 2 6, so it requires 2 more electrons, so the valency is 2. Okay, valency is 2. Valency of 16th group elements will be 2. Valency of 16th group elements will be 2. And valency of 17th group elements will be 1. We know that valency of chlorine is 1 because it can accept only 1 electron, chlorine. Okay, so the valency of 17th group element is 1. And 18th group element valency is 0. Valency of 18th group elements is 0 because they already have 8 electrons in the outermost shell. That's why they will never take part in a chemical reaction, and they are known as noble gases. They will never take part in chemical reaction. So this is how you should by heart the periodic table. By heart the first group elements, second group elements, 13th group elements, 14th group elements, 15th group elements, 16th group elements, 17th group elements, 18th group elements. 18th group elements. First group element valency is 1. Second group element valency is 2. 13th group element valency is 3. 14th group 4. 15th group 3. 16th group 2. 17th group 1. Okay, 17th group valency is 1. 1. 17th group valency is 1, and 18th group valency is 0. You have to by heart this valencies and groups, elements for the next class. This is your assignment. Okay, by heart all these elements for the next class. Is it clear? That's all for today. We'll discuss the remaining topics in our next class, and also we'll clear the doubts in our next class. Okay.